Okay, we're going to start Unit 7, relationships in right triangles. So trigonometry stuff. So just to begin, you have to know that inside a triangle there's 180 degrees. Okay, so 180 degrees inside. So when you're calculating some measurements, so in this first example, 55, 60, and what? You could add up 55 and 60, so 115. So then 180 subtract 115 and you get 65 left over. Okay, so see if you can do those three on your own. So just remembering 180 degrees inside a triangle. Okay, Pythagorean theorem. Let's talk about it. First of all, you need to understand that in a triangle, the location of the right angle and the side across from it is called the hypotenuse. So the hypotenuse is always, it's always the longest side. Okay, that's one thing to know about it. Always the longest out of the three, and it's always across the 90 degrees. Okay, so here's the formula. If I'm given two sides and want to know the third side, okay, I'm going to give you another one here. Okay, so two sides and I want to know the third one. You use the Pythagorean theorem. So it says a squared plus b squared equals c squared. Okay, now the most important thing to know is that I don't care about the a and b. I could go this side plus this side, but the c squared has to be the hypotenuse. Okay, so you add the two sides squared, you add the smaller two sides squared, and then that should be the third side squared, the hypotenuse squared. Okay, so in this case, the first one here, I'm adding the two smaller sides to get the longest. Okay, so we go 3 squared plus 4 squared equals x squared. So 9 plus 16 is x squared. That adds to 25. So my solution is 5. Okay? Now, in the second example here, do you see that I'm given the longest side? So I want to find a side that is shorter. So if I'm finding something that's shorter, I would subtract. Okay, but you have to obviously take the biggest side first. So 13 squared subtract 12 squared, right? Because otherwise you get a negative number equals x squared. So all I did was move around this formula because I have this and want to know this. So you see if I take one of these over, I would subtract it. Okay, so that's all we're doing to the formula. So 169 subtract 144 equals x squared. So that's 25 equals x squared. So my solution is 5. Okay? So that's the biggest thing to know when you find hypotenuse. You add. When you find a shorter side, then you subtract. Okay, there's your rules. Okay, so if you look at some of the examples I gave you here, there's a triangle park in the middle of 3 yards. Each yard is built in a square. So when I drew this diagram, 1 unit was representing a length of 9 yards. So what is the size of each yard on the diagram and the actual yard? Okay, so you can see that this is 4 units, 1, 2, 3, 4. So A is 4, B is 3, and C is 5. Okay, so now you can see that if I square 4, I get 16. If I square 3, I get 9. And if I square 25, or 5, I get 5. So can you see why the formula is working? 4 squared plus 3 squared is the same as 5 squared. Okay? If we find the actual size of each yard, we have to make sure we're just timesing by 9. So in the diagram, this would be 36. 3 times 9 is 27, and this is 45. Okay, so now let's try this. What's 36 squared plus 27 squared and 45 squared? Does that work to be the same? Okay, so 36 squared. You have a squared button right here. If you push second function exponent, 36 squared, 1296 plus 27 squared, 729. Let's add those. 2025. Okay, let's see if it's the same as 45 squared. And it is. Okay, so those are at a right angle. Okay, let's go to example 2. Measure these with a ruler and decide if they are a right triangle or not. Okay, I'm actually going to just give you some examples here. So here's one example. I'm going to go 14 and 10 and let's go 15. Is this right or not? Okay, so here's what you would do. 10 squared plus 14 squared, does this equal 15 squared? Okay, so 10 squared is 100. 14 squared is 196. Add those together, you get 296. 15 squared is 225. So no, it's not a right triangle. Okay, another example. 7, 24, and 25. Okay, so if we are checking if this is a right triangle, this is our hypotenuse, because it would be the longest side if it is a right triangle. So I'm going to see if 24 and 7 squared will be the same as 25 squared. Okay, this, you can't put 24 over here, right? Because if it is, it's got to be 25, the longest side. Same as here, I picked the longest side to check. Okay, so 7 squared is 49. 24 squared is 576. Let's add them. And we get 625. Now let's take 25 squared. And we also get 625. So yes, we can conclude that that's a right triangle. Okay, next example. How far must the third baseman throw the ball to second base after picking up the grounder? Okay, so we want to know what's the distance from here where he picked up the grounder to throw it there. we have, I drew that really bad, sorry. Redraw. We have a right triangle, we have 10 and 27, and we want to know that distance. Okay, so we're going to go 27 squared plus 10 squared equals the distance squared. Because that's a hypotenuse, it's across from the 90, so we're adding. So 27 squared is 729 plus 100, so that's 829. Okay, so now I go into my calculator and I go square root button. See it right there, the pi symbol on mine, second function pi. 829 equals 28.8. And this is in meters. Okay, last example. Beth needs to find the diagonal of this square room. Okay, so that's all that's given, and then square room. I know that, and I know that if it's square, it means that both of those are the same. So I'm finding a hypotenuse, right? So that means I'm adding the formula. So 3.5 squared plus 3.5 squared is the distance squared across there. So 3.5 squared is 12.25. So that adds to 24.5. So I square root it. So square root is 4.95 inches. All right.